Hello everybody, this is a tropical cyclone update on Tropical Cyclone Seru, which has recently developed in the South Pacific just east of Vanuatu. Let's get straight into it. This is satellite imagery now of Seru for this morning, Zulu time right now, though it is the evening now for the locals in the area. What's happening right now is we got a nice, formidable central dense overcast here, nice convection, very cold cloud tops as is usual in the South Pacific, but we've got that nice evolving structure underneath, and we can see that with microwave imagery here that we got. Although slightly old, it is from 5 hours ago. At the time of recording this, it's 7:42 Z. But we got a nice AMSR2 pass, which does show us a nice curved band in a course structure, which is pretty good. It does honestly represent what we kind of have here. It fits, it matches, and even with extrapolation, to be honest, we could probably have a better, more formidable core structure underneath as well. Since that pass, with the evolving convection, we can see some elements of that convection wrapping. We can see, I mean, you'll guys see at the end of this loop in a second, you can see some of that's wrapping. Let's roll that back again. Yeah, some of that convection's wrapping, very subtly, but you can kind of see it, and it is there. And we do see an evolving structure, and that's pretty good. It does show that it's intensifying as was forecast. Though what we're currently undergoing through is a relatively short, quick intensification phase that might soon be going away. It might soon be stopping. Let's take a look at some of the agency forecasts at the moment. So, the JTWC at 3Z, this was this morning, 4 hours ago, and they initialized the forecast at 45 knots. That's what they estimated it as for 0Z. That's the intensity they had, and they expected only gradual strengthening to a peak on the 27th. That will be in 2 days' time. 27th 0Z. They want it, or they forecast it to peak at 60 knots. At least they did. That's their last forecast. With some steady weakening going afterwards, going into the 28th and into early March. And during this time, it will be heading on a nice southeasterly direction before making a more due eastward movement. A more eastward shift, and then it might even make a rebound further north, back towards the equator to some extent, probably because it misses some sort of trough late in the future. So we'll take a look at that in a bit more detail in a few minutes. And that's their prognostic reasoning. Here they have a nice description of what's happening and why they expect their thing. It's a bit shorter than their usual prognostic reasonings, but we'll take a look. So what do they at the moment see? They see that there is a consolidating system with fragmented formative banding, loosely feeding into a deepening and expanded central cold cover. That is totally obscuring the low-level circulation. Now, first of all, I am a bit skeptical of this wording. Why? Central cold cover is usually a big blow-up of convection, an organized kind of blob, as people would like to call it. Big blob of convection that's just there. It's not very organised, there's no real structure underneath it, and what contradicts the fact that it's a central cold cover. And this is following the Dvorak technique, by the way. This is what they have it. This is what the technique actually has it written as. It's literally a disorganized blob, and what we can see here is there's clearly an element of organisation here, even right at the time of the advisory almost. This is a very organised curved band structure. There's not really any sort of blob in any way. Although yes, we do have quite a bit of a heightened like sort of a blob-like area of convection there. We see that's associated with a larger part of banding wrapping into the inner core, into the inner circulation, and frankly, objectively, following the Dvorak technique, I would not refer to that as a central cold cover. But the JTWC does its own thing, so we'll let it do its own things, and we'll see what it wants to do. Next, we'll look at later on That is totally obscure in low-level circulation, yeah. The initial position is extrapolated with low confidence from the irregular LLC or low-level circulation feature in the 2203Z GPM microwave image. I don't think they saw that microwave image that came in. I think that was least expected. I feel like they probably looked at it after the advisory and they were, I guess, a bit shocked to some extent. I don't know, but they probably didn't see that microwave image, but it definitely contradicts with what they've written in this advisory. And obviously, it's as a forecaster, it's important to know that all the information coming in is hard to assimilate for you to use, and then you have to kind of use it for the advisory. It takes time, and it's a hard job as a forecaster to try and take in all this data that keeps coming in. It's not the easiest thing in the world. And 45 knots is based on the overall assessment of agency and automated estimates, reflects a slight 6-hour convective improvement. And then there's a favourable environment, which I will go into in a second. And what do they have? Well, their own Dvorak fixes. They have it as a 3.5, which on face value 55 knots. For some reason, the SAB is 1.5 T numbers below them, which I don't agree with this. I mean, let's go back to this. I can easily get a pretty nice curved band estimate of maybe 0.6, 0.7, 0.8. That will be a 3.0. To 3.5. And obviously I'm not going to apply the Dvorak technique right now. I don't have the resources to do so. In the form of I've got to get through the other stuff that's a bit more important right now, but that's roughly what I would probably get. And it would align with the development trend and the microwave imagery that we have here, so pretty good. Now, what's their forecast reasoning? And why do they have a forecast that goes like this and then it goes back quite towards? Well, let's take a look. Under the steering influence of a subtropical ridge to the east-southeast, which we'll take a look. And then a favourable environment will fuel slow intensification, which we haven't actually seen. We've seen something more like quite rapid, and a peak of 60 knots by hour 48. Increase in vertical wind shear and cooling sea surface temperatures will cause a gradual erosion of the system down to 35 knots by hour 120. And what did the model guidance say? What have they had analysed? Well, they say that there's a spread of 88 nautical miles at hour 72, and more erratically to 429 nautical miles by hour 120. Medium confidence to near to mid-term portion, and then low confidence to the extended portion of the forecast. And there is medium and low confidence in the intensity forecast at the respective portions of the track. Left of track outliers include the UK Met Office, AFUM and UEMN that recurve the vortex equatorward after hour 72. But they forecast that themselves. And if we take a look at the model guidance that we have here, this is Alfred. I'm looking at completely the wrong storm here. Seru. Let's take a look at Seru here, and look at the guidance here. To be quite frank, there's not much certainty. First of all, this model is outrageous. Clear outlier. The AFNI, which I believe is the GFS, goes that way. Oh, nice sharp turn back equatorward, and then you got your NavGem and HAFS models that take it in mainly the direction of the JTWC. It could just be a case of a lot of the guidance not being yet ready available. I'm sure Tropical Tidbits actually has a lot of them. Actually, I'm not sure actually. Most of your guidance plotted on these kind of plots will be in North Atlantic, where most of the guidance is accessible and available to plot. Out globally, though, in the South Pacific, there's not much guidance to really look at, and not really that much to be able to make a suitable, conclusive argument or kind of just a conclusion in general. But from what we have, JTWC, we'll take a look at the guidance in a second, what the global guidance say. I've already got these GFS, Euro, I've already got everything ready to look at, but at the moment this is what their forecast is relative to some of the tracks plotted. So yeah, we've looked through the JTWC prognostic reasoning. We can take a look at the Fiji Meteorological Service forecast track now, and they've got Very weak intensity for what we've got right now. We're probably nearing hurricane force winds now. We're probably nearing hurricane status, really, or hurricane equivalent. And they've only got it as a Category 1 tropical cyclone. That is a low-end tropical storm on the severe Simpson hurricane wind scale. They're following the Australian scale, by the way. That's why their numbers might appear a bit weird. And yeah, that's when they've initialized it at 427Z. So that's after the JTWC advisory. And surely they would have seen this. But Fiji Meteorological Service, they are known to be very often underestimating systems. And I just don't think they have the capacity or skill. Honestly, I'm not one to talk, but compared to the National Hurricane Center, we don't see them performing so well. And that's fairly objective. And that's what they've got, yeah. Only Category 2, strengthening at peak fairly imminently, before weakening to Category 1 later down the line, as it makes that more eastward turn. And as I've looked into, that is the current under the hood structure. That's the latest microwave image that we have available. And again, yeah, we have that curved band structure that has probably evolved recently to this point now. Now, what does the environment say? Right, well, let's take a look at the environment here. And multi-model diagnostic comparisons here. We have a best track, GFS, the European Sweet ECMWF, the HAFS-A, D-shape, and we also have the JTWC forecast. So what do we have at the moment? So, steady intensification is what most of their guidance has, with a peak near the 27th of February, 0Z, and that comes at around a mean of around 60 knots-ish, which I see why the JTWC actually went with that intensity, but I feel like we cannot take multi-model consensus at face value all the time. Models can tend to not be as accurate, especially when it comes to intensity. They're not really on the dot accurate all the time, and the consensus as well can be either skewed, biased, or, you know, depending on what all the models think, all the models could even be too low because they don't see any sudden changes, any sudden evolutions which might change later down the line what the outcome is. And as we see here, we have this. We're at 6Z right now, and the new JTWC intensity estimate, despite no advisory being issued, one did come out actually for 6Z, and they have it estimated as 60 knots, which already, as I said, it's nearing hurricane force winds probably, given the recent evolution, and I would agree with the estimate that JTWC put out. But that already means that they've already reached the peak intensity forecast for February 27th. And yeah, we're already there. And if we're going to follow this continued evolution, intensification evolution, if we're going to continue to follow what the models have, even if the peak's a bit lower, you know, we will reach somewhere around maybe Category 2, following the trend. We've still got plenty of time following the guidance, and why is that? Well, first of all, let's take a look at the deep layer shear. Now, what I'm going to say is don't take this at face value, because there will be other parts of there will be other elements of the shear. You've got directional shear, outflow shear, that will, to some extent, could benefit or be even more drastic for a system. This is shear averaged out from 200 millibars to 850 millibars. That's from the low levels to the mid mid levels to the upper levels. It covers all layers of the atmosphere, and that's what deep layer shear is. And usually you don't want to take that face value, because there might be low amounts of low-level shear and then decent amount of mid-level shear, which would be quite detrimental, and then the average shear, deep layer shear through all the deep layer, might be lower than what is actually representative for the system. But nonetheless, it can still be good as long as you know the environment that you're kind of in. And most of the time, deep layer shear, as long as it's low, can be fairly good. It does suggest that the environment is actually not too bad. And until 26th, we're looking at a pretty decent environment where it sticks around 10 knots or under, and that's GFS, ECMWF, and the HAFS-A model, regional hurricane model. They all generally agree with the ECMWF with the lowest deep layer shear. and then that deep layer shit skyrockets. But I do feel like that's when it begins to interact with that trough, so any outflow shit that's around within the area could continue to intensify the system until at least the 27th, when models are expected to peak. Sea surface temperatures are going to be quite good. We're currently at 29, slowly decreasing as the system heads southeastwards, as we see the track here. Head southwards, it will enter cooler waters later down the line. It's forecast to breach the 26th degree isotherm on the 28th of February, and that's in agreement with GFS and HAFC. And then it just hovers around 25, 20, near 26, and that's when it's expected to remain a weak system, but the JTWC doesn't expect it to dissipate completely, which again, the sea surface temperatures are marginal and could probably upkeep a system at that intensity. And then obviously embedded within the South Pacific Convergence Zone, the mid-level relative humidity is actually pretty good, but steadily decreasing as it increases in latitude, and that is absolutely no surprise. Let's take a look at the GFS ensemble plots here. What there actually is here, looking at a bit of a closer detail. So what influences are there? So we saw the JTWC mention that ridging to the east-southeast. I think this is the kind of ridging that they're on about. And yeah, absolutely, that will steer it there. But we've also probably got influence by what's left of Tropical Cyclone Ray. That will be continuing to also follow the upper trough that's getting, or the deep layer trough that's going to pick it up there. And then I think there's going to be a nice downstream effect here, where it's going that way, picked up by that trough, and then obviously while that ridging is in play, sure it is. It's probably just going to be a train of systems where this one will follow Ray, well, sorry, Seru, this one being Seru, that will follow what's left of Ray, and when it gets picked up by that deep layer trough, and then yeah, we got that downstream effect for Seru as well. And it just moves in the direction of that arrow, but where we do see that rebound, could be where it misses that trough, like I mentioned before when I went over that forecast cone. That trough goes away, goes off the plot. It continues going eastwards, and then because it's a bit too far and that downstream effect isn't really strong enough, it could probably stay. It could probably stay beyond, and it probably won't get picked up, and it will be within that complex mixed steering environment where we've got southerly flow coming from this ridge there. We've got ridging over here that gives it decent northerly flow, and it has very limited area to go. It'll be somewhere around there. Why can't you see it there though? It's because it's probably died enough. Or died enough is a bit of a weird way of saying it, but it's probably weakened enough so much that it has simply gained its should I say it's lost much of its vertical extent. It's become a shallow system, and therefore it is more prone to low-level steering flow, which again is because these are deep layer ridges with northerly flow there and southerly flow there. Very complex competing steering environments, and once that trough is gone, it is yeah, once Ray and once that trough is passed, blocking, very evident blocking, and it can't go anywhere. And that's what we got, and then it just kind of stays there. Nothing too significant until eventually there's probably some weakness where I've highlighted, where I've circled, and then it does end up getting that way, but not after it elongates and dissipates a bit further, because that environment doesn't improve. What did I want to look into? Sea surface temperatures, again, we can see here, following a track. Yeah, I've done this again. Following a track that goes that way, I need to get a bit of a better colour there. Once taking a bit of a track like this, we can see how those sea surface temperatures will be good for a good day or two, but they will decrease gradually. And then yeah, those sea surface temperatures will become more marginal as time goes on. Why do I have these popping up? I don't know. Right, and that's what we have with the kind of steering and where those sea surface temperatures will be going through. And then that's for track again. That's kind of what happened. I think I've looked through this. This is, they're going to take a bit more at the environment. bit more of a look at the environmental conditions and why strengthening is occurring. Let's take a look at the reanalysis that we have for GFS. So, we've got 995 pressure. I'm doing this again. 995 pressure. 995 millibars. That's generally okay tropical storm. And we can see that really nice divergent environment. Almost radial, if anything. Almost radial. We can see there that goes everywhere. All that anticyclonic flow. And partly, this is what is shearing rain now, and that's why it's weakening. But it's within that broad upper level anticyclonic South Pacific convergence zone envelope, and when you have convergence in the surface, outflow and flow is forced upwards, and it will have to go somewhere. So that's why we've got this broad upper level anticyclonic flow, and it's really dominating the space right now. And then, look at 6 hours later, that pressure ends up dropping a whole 9 millibars. You guys could probably see that there. 986. Got 986 as the pressure there. That's a 9 millibar drop since since 6 hours ago. And again, that really does show that anticyclonic flow, really broad, is coming into play. It's really supporting it. Excellent environment in terms of upper levels. Really good upper level divergence, venting into the subtropical jet and just going everywhere. That's exactly a really pristine upper level anticyclonic environment that even a upper echelon system could really make the most out of. It's really good, and that's why we got this pretty good, decent intensification. Obviously that doesn't tell the whole picture, that doesn't tell the whole story. We also got to take a look at forecast soundings, or analyze soundings even. And yes, we do see that there's a bit of max shear at 20 knots, and that covers most of the levels. But again, we've still seen evolution because our outflow that we got, that really big outflow regime, that's really helping it offset that shear that's around. We can see here that there is this is the storm vector that we have. Or let me circle that again. Storm vector there, and the only flow that's really aligned is above 500 millibars for the most part. It's either weak or it's aligned to some extent, but that's not really the most important kind of level that we need to observe. We need to observe the low level to mid levels there, and then, yeah, they are a bit detrimental, at least for Seru Z when it was 6 hours ago. And for the most part, low level winds, we've got a really strong southerly component that comes and extends up to 20 knots. And we've also got a lot of the mid-levels that extend up to 15, or just over 15. But much of the upper mid-levels as well do near the storm vector. So, I guess it's not the worst environment, but, and you know, we can definitely see that there is southerly flow. So, net shear is a bit lower than what is actually presented here at face value. But nonetheless, there is still an extent of some shear. And we can see that is reflected in the relative humidity plot there, where a lot of that moisture, a lot of that bulk moisture there is not really, it's not particularly organised at this stage. It's offset from the centre a little bit. But nonetheless, we still see that pressure decrease because the environment prior to that was a little bit better here. Much weaker winds, still aligned. So that's decently good. 10 knots of max shear here evident with a 4 knot steering flow. Obviously the environment, you know, we saw does get a little worse, but again, that outflow regime definitely offset. What happens later down the line? Well, okay, max shear 26 knots. Again, mainly deep layer, and it's not really that different from the last sound that we got. This is kind of closer to what we got now. Your deep layer shear for the most part is 11 knots. And that's only because some of the upper levels are considered. But mainly, for most part, the bulk shear, the kind of maximum shear that we have here, covers most of the deep layer, and that's much higher than the 11 knots that we have here. That's 26. Why? Well, there's quite a bit here that extends. Again, we have the mid-level flow extending to 15 knots at 750. Though aligned, generally, the best flow is around 500 millibars, where it is literally at the storm vector. It's literally the same. So again, still some shear, though it's fairly in the same direction. It matches the flow of the storm, and when the storm's going, storm vector and shear vector generally aligned. It's just that the 850 to 500 flow, is just slightly stronger than the storm vector. But again, that outflow regime is really good, so it should be able to offset any kind of shear effects that may be lingering around. And plus, with any shear that is around, we also got to note that the relative humidity, as it's embedded within the South Pacific convergence zone, it's high, 86%. That's pretty good for a tropical system, and any moisture will be fairly plentiful in the area. So there's no significant dry air to really affect. Unlike we saw with Bianca yesterday, where it suffered a dry air intrusion. There was a lot of dry air within the vicinity. We don't have that problem here. And generally speaking, with this kind of component that there was around, not too different of a sounding compared to Bianca from what we saw yesterday. Although there is less of a westward extent, but for sure somewhat similar in terms of direction being not the issue. Instead, it's kind of the flow strength. Let's take a look at the ECMWF to compare, and we can see here very evidently that again, we saw some pretty good intensification here. If we look at well, it's not happened here yet, but it's forecast. If we look at 6E now, so this is where we have it. This is 6E, and we look now at 12Z. There's a drop of 4 millibars, and then going to 18Z, it's 9A5. It drops another 5. Why? Well, the environmental conditions, again, very similar kind of sounding profile. Where it's not too similar, but you can kind of see differences, the similarities here. Again, just over 15 knots of 850 millibar flow, but any higher than that, really, you got it more closely aligned to the storm vector, and shear overall not too bad. We got max shear at 18 knots, generally covering most of the deep layer. Overall deep layer shear 14 knots. It's fairly good in the upper levels, but again, that's not really much of interest. We're looking at this area where the 850 to 500 millibar flow is. And for the most part, generally, again, aligned in terms of direction. With flow, it could be a bit better, but again, net shear is lower than what's suggested here, and for sure still strengthening because that outflow regime is really good. And later on, it actually does improve a little bit, that environment. We can see that it's a bit more of a wonky holograph, but we can also see that there is quite a bit of a Still a bit of a flow there, 850, 15 knots, but again, it's wonky. It takes its time a little bit as it goes through that holograph, as it goes through, and it does lean a bit to the lower side now. And again, that outflow regime, I'm going to keep repeating it, it's very important. It's fairly good. Now, for why it ends up strengthening here, well, exactly what I said. And what happens with the flow now? Again, it's a fairly similar sounding profile, except that southeasterly direction continues, but that flow becomes more southerly now at this point. Again, not too detrimental, nothing to worry about really. Really, with the storm motion around 7 knots here, it is it's not too much. It's still roughly similar, the kind of direction that the storm vector and the shear vector is. Still kind of similar they are. Again, not too detrimental of a profile. If you can see here, at 400 millibars, nothing too drastic. We're focusing kind of on this area, and for the most part it's aligned. It's not too bad of a profile. It weakens 1 millibar here. Again, nothing too interesting. It continues staying here on that same kind of, I guess, organization on the holograph. The wind profile down here as well, not too different, except it does change a little bit here. Now this is again 10 knots of wind, and this is when the kind of steering flow also kind of stays at 7 knots and might even begin to increase pace here, and where it will continue to increase in pace. Here we see that there is more of a curved hodograph that extends more to the western portion, and this is low levels. Most of the mid-level flow is okay. It's aligned to some extent. This is kind of where it's going, or it will be going that way, and the flow for the most part is going that way. Not too detrimental. It'll be okay. Low-level flow might be a bit of a concern, but again, it's not too detrimental. It's southerly for the most part. Though the max shear has increased to 25 knots. Why? This pesky upper level does peak at 50 knots, going northeastwards, sorry. That's where the flow's going. It's a bit of an outlier in terms of how the hodograph kind of is composed. It's not too much to worry about anyway. It keeps that kind of composition for a bit. The 500 millibar flow kind of extends, well, it widens in both directions really. Not only does it go westwards, the mid-level flow, but it goes also a bit eastwards. This is kind of where it starts getting really complex and all over the place, because that trough ends up coming in. Now this is where the shear really becomes impactful. We can evidently see here, even here really it begins. We can see that relative humidity, that moisture, that bulk of moisture does become displaced from the center. And we also can see that is because the flow here, 850 millibars, is at 20 knots, or near 20 knots. And that's fairly high. And that mid-level flow obviously has to come back to where it is, to obviously align with the flow further aloft there. And yeah, it does try and get back to the storm vector, but again, most of the flow is actually fairly displaced from the storm vector. This is where shear becomes really impactful. You got very intense northerly flow now that comes into place and will be fairly impactful, regardless of the outflow regime at this point. This is probably when it will start kind of maintaining its intensity, though the model depicts some additional deepening at this time, which again I can't rule out. This is nearing the peak, near the expected model consensus peak on the 27th of February. This is just before that now. Now the max shear total really starts getting there now. This is a very widely extended hodograph, goes all over the place. Again, this is a very disorganized flow. This is much away from the storm vector motion. This is not a particularly favorable hodograph. And this is when you get most of your convection displaced. It does still try to hold on. This is not a completely dead, dry environment. It's not. You still have quite a bit of relative humidity near the center. That probably does suggest the convection will still be blowing up, and that circulation is still holding fairly well. But nonetheless, it's still quite a favourable hodograph, where you got some easterly ones now actually popping up in the lower mid levels, and yeah, the upper mid levels aren't really completely aligned. The flow could definitely do with a bit of intensification. A better look here. Let's just draw our boundaries here. Some easterlies in the lower mid-levels, northerlies, westerlies. It's not a good environment for vortex development. And that's where it essentially starts to die. Now I can't go any further because the soundings haven't loaded yet, but that's a general kind of environmental analysis of what we have in the near term, which is what matters the most, because it's going to be dying at this point, and this is certainly not going to be peaking later down the line on the 28th. And a better look at kind of where we have that trough interaction, because we've looked at the initial outflow regime, which is good, but obviously as we see it being pulled that way, because Ray and the further down deep layer trough that passes, Seru will be heading into the subtropical jet. It won't even be interacting with it in any significant way. Obviously, this is its nice peak on the. This is its nice nearing peak period on the 18th. Sorry, the 26th, 18Z. Obviously, we've still got that nice outflow going around, and some of it goes into the subtropical jet. But then, shear really starts to kick in because as it moves this way, very broad anticyclonic flow that's present in this kind of area will start going into it, aka the subtropical jet also being part of that. As it kind of nears it and it goes into it, that flow really starts rushing in, and it's going to really go through it, and that's going to be a pretty big hit. That's why that sounding profile was so widely extended, and it was all over the place, because this flow is not particularly favourable. And then yeah, it stays there, and because it's literally got nowhere to go and it's just trapped under that subtropical jet, it's bound to die at this point, really. After being long enough under such terrible environmental conditions, it's not going to bear well, and that will be the end of Seru, to the south of Fiji. I think I've looked through all the soundings here. I'm not sure if I've looked through the GFS to total amount, but yeah, I mean, very similar evolution there. Very similar sounding profiles. Models are generally in good agreement. And yeah, we'll go back to the multi-model diagnostic comparison. Yeah, fairly consistent between all the models. That's kind of what we have there. And you know, given a few more, 1 or 2 days, I feel like this structure could definitely evolve into something fairly intense. We could be looking at a category 2 here. For now, because we've looked at some of the model guidance that we had a bit earlier on, a few days ago, did suggest such an evolution. Because we're already getting such significant intensification earlier on, we could be getting for a much significant overperformance, we could be getting something fairly significant that the models won't have been anticipating. We'll just have to keep looking. This is definitely an evolving structure that's doing pretty good for the moment. And yeah, we could see quite a bit. At the current intensification rate, which I don't expect to stop anytime soon, it might see a bit of a lowering in the intensification rate, obviously as fluctuations can go and can happen. We'll see, but for the most part, this should continue intensifying fairly well, and we should see a pretty decent peak, maybe with an additional 20 knots intensification. That's probable, seeing the current environment and observing the soundings as I have today. So, thank you all for watching. Hope you guys enjoyed, hope you guys found that informative, and hope you guys have gotten the information that you wanted out of this video. Make sure to drop a like and subscribe. We shouldn't see any impacts. Obviously, Vanuatu's having a bit there, but it's moving away, and for the most part, this should be heading out in open waters with no significant impacts around the place. Hopefully, this could be photogenic without having to impact many people. And yeah, we'll see how this evolution goes. Keep tracking, and I hope you guys enjoyed. Thanks for watching, guys. I'll see you guys in the next one.